Logistic model by differential equations. If the growth rate of a population is proportional to the size of the population grows exponentially. In reality, this model is unrealistic because environments impose limitations to the population growth. A more accurate model postulates that the relative growth rate P prime over P decreases when P approaches the carrying capacity L of the environment. The corresponding equation is the so-called logistic differential equation like this. dp dt equals k times p times 1 minus p over L, provided k is the constant of proportionality, p is the size of the population at time t, and L is the carrying capacity. This is the graph of a logistic model. Carrying capacity is L. This is the point of maximum growth before it begins to slow. This point, y coordinate is L over 2. Let's use t submit to show this x coordinate. So this population equals L over 1 plus e to the power of negative k times t minus t submit. We can write down L over 1 plus c times e to the power of negative kt. For this c is a constant, basically means e to the power of k times t mid. L is the limiting capacity. K is the logistic growth rate. T is the time. For example, let P of t be the population of a certain animal species. Assume that P of t satisfies the logistic growth equation. Solve this logistic growth equation. First of all, we need to work out this fraction. dp dt equals 0.18p times denominator 250 minus p. Then this is a separable differential equation. dp over p times 250 minus p equals 0.18 over 250 dt. 1 over p times 250 minus p equals a over p plus b over 250 minus p. Get rid of p times 250 minus p. We got 1 equals a times 250 minus p plus b times p. When p equals 0, 1 equals a times 250. So a equals 1 over 250. When p equals 250, 1 equals b times 250. So we get b equals 1 over 250. So we get 1 over p times 250 minus p equals, take out 1 over 250. We got 1 over p plus 1 over 250 minus p. Remember this as a formula. 1 over p times L minus p equals 1 over L. 1 over p minus 1 over L minus p. So we got 1 over 250 times 1 over p plus 1 over 250 minus p dp equals 0.18 over 250 dt. Get rid of 250, then take integral both sides. We got natural log of absolute value of p plus natural log of absolute value 250 minus p times coefficient of p is 1 over -1 equals 0.18t plus c. Organize, get rid of absolute value. Natural log of p minus natural log of 250 minus p equals 0.18t plus c. So we get natural log of p over 250 minus p equals 0.18t plus c. We are given when t equals 0, p equals 120. T equals 0, p equals 120. Natural log 120 over 150 minus 120 is 130 equals c. So c equals natural log of 12 over 13. Therefore, natural log of p over 250 minus p equals 0.18t plus natural log of 12 over 13. We will put all natural log together so that we can condense the log. Natural log of p over 250 minus p minus natural log of 12 over 13 equals 0.18t. Condense natural log of p over 250 minus p divided by 12 over 13 means times 13 over 12 equals 0.18t. Put e as the base both sides. We got p over 250 minus p times 13 over 12 equals e to the power of 0.18t. So we get p over 250 minus p equals divided by 13 over 12 for both sides, 12 over 13 e to the power of 0.18t. Cross multiply. 13p equals 12 times e to the power of 0.18t times 250 minus p. 13p equals distributive property 12 times e to the power of 0.18t times 250 minus 12 times e to the power of 0.18t times p. This is a linear equation. Put all p on one side. We got 13 plus 12 times e to the power of 0.18t times p equals 12 times 250, 3000 e to the power of 0.18t. Then p equals 3000 e to the power of 0.18t all over 13 plus 12 e to the power of 0.18t divided by 12 times e to the power of 0.18t. We got 250. 13 over 12 e to the power of negative 0.18t plus 1 organize equals 250 over 1 plus 13 over 12 e to the power of negative 0.18t.